probability is denoted as probability A by B. That is the conditional probability of the event A given that the event B has already happened. Okay, now probability of A by B means probability of A intersection B by probability of B. Okay, so probability of A given that probability of B. So probability of B already has happened. Okay, and so we can explain like this way. Suppose total events at 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Clear? Now out of 10 events, B appears at 1, 2, 3, 4, 5 and 6. Okay, and A appears say 1, 2, 3, okay, and 4. So probability of A given B, that is what? Probability of B. So how to calculate probability of B? Probability of B is nothing but probability of occurrence of B 1, 2, 3, 4, 5, 6 and total events at 10. Clear? So it is 0.6. Similarly, probability of A intersection B. So common events are there 1, 2, okay, and say 2. So probability of A intersection B is what? 2 by 10, that is 0.2, and probability of A by B is what? 0.2 by 0.6, that is 1 by 3. Okay. Similarly, we can write like this way. So probability of A by B is a conditional probability of occurrence of A when the event B has already happened. Now similarly, if it is PB by A, that is probability of A intersection B by probability of A. That means conditional probability of occurrence of B when the event A has already happened. Clear? Now, next, multiplication theorem. Now, if you rearrange this one, then we can write probability of A intersection B is equal to probability of B into probability of A by B, where probability of B should be greater than 0. Or same way, from this equation we can write probability of A, probability of B by A, where probability of A should be greater than 0. So probability of B by A represents conditional probability of occurrence of B when the event A has already happened, and probability of A by B is the conditional probability of happening of A given that B has already happened. Okay, now so we can write this if A and B are dependent event. If both A and B are, so we can write these two if A and B are dependent. If they are independent, then we can write A intersection B is equal to probability of B, probability of A. Similarly, probability of A intersection B is equal to probability of A, probability of B. That means, so if A and B are dependent, then we can write this equation. If they are independent, so in this case it is probability of A. Clear? Now if they are independent, we can write probability of B by A is probability of B. Clear? So in summary, if A and B are multiplication theorem, if A, B are dependent, then we have to use these two. If they are independent, we have to use these two. Clear? Similarly, for conditional probability, we can write probability of A intersection B by probability of B. Okay, and probability of B by A is equal to probability of A intersection B by probability of A. Okay, so if they are dependent, okay, and if they are independent, then probability of A by B is equal to probability of A, and probability of B by A is equal to probability of B. Okay, now it is multiplication event. So what is independent event? Two or more events are said to be independent if the happening or non-happening of any one of them does not in any way affect the happening of others. Clear? Next, I can give you two examples. Suppose, what is the probability that drawn card is king? Example, what is the probability that drawn card is king and the color is red, and color is red? So the drawn card is king and the color is red. That means probability of key given that red. So that color red is already happened, and we have to identify out of red how many kings are there. Okay, now the formula is very simple: K intersection R divided by probability of R. So total number of, so what is the probability of R? So total number of cards, say 52, and out of 52, 26 are red. Clear? And what about the K intersection R? So total number of cards 52, out of reds 2 kings are there. Out of 2 reds, out of 26 out of cards, 2 red kings are there. So we can write it this way: 2 by 26 is the answer. That is 1 by 13. Okay, now you can take another example. That is called, there is one concept that is called market basket analysis. Market basket analysis. Clear? We may use this particular concept in association rule. Association rule in data mining. Okay, now what is the probability that a customer purchase milk also purchase egg? What is the probability that a customer purchase milk also purchase egg? So what is the probability of egg given that milk? So probability of egg intersection milk divided by probability of milk. Clear? Now we can solve the other problem also. Now just take one simple example. The odds that a person data on the readership of a certain magazine show that the proportion of male readers under 35 is 0.40. Okay, proportion of male reader under 35 is 0.40, and over 35 is male reader over 35 is 0.20. Okay, if the proportion of readers under 35 is 0.70, so proportion of reader under 35 is 0.70. So these are given. Clear? So assume male, M for male reader, okay, under 35, and so probability of male reader and under 35 is equal to 0. Under 35 it is 0.40, and probability of male reader over 35 is equal to 0.20, over 35 0.20, and probability of under 35 is equal to 0.70. So these are given. Okay, now find the proportion of subscribers that are female over 35 years. That means they are female, that is small male over 35. Clear? We have to identify this one. Also calculate the probability that a randomly selected male subscriber, that means male is already selected, subscriber is under 35, so it is a conditional probability. Clear? So first one is what? So aim for male, U35 is under 35. So first given is what? Male under 35. Say male and female under 35 and over 35. Summation is 1. Clear? Now aim under 35, it is 0.40. Aim over 35 is 0.20, and probability of under 35 is 0.70. So here addition is what? 60. So 1 minus 0.60, it is 0.40. 0.40, 0.70 minus 0.40, it is 0.30. 0.40 minus 0.20. So addition of these two is this one, addition of this to this one, addition of this to this, addition of this is this. If you add these two, that answer should be 1. If you add these two, answer should be 1. Clear? Now male, female over 35, female over 35, answer is 0.0. So female over 35 is 0.10 from the table. Clear? And we can write under 35 male, that means probability of under 35 intersection male divided by probability of male. So what is the probability of male? Probability of male is 0.60. Okay, so this is nothing but probability of male, this is nothing but probability of female. Okay, and this is probability of under 35, probability of over 35, and under 35 and male, under 35 and male, it is 0.40. So answer is 2/3. Okay, now just solve another problem. From a city population, the probability of selecting a male or a smoker is 7/10. Okay, male or smoker is 7/10. Okay, and okay, a male smoker is 2/5. A male smoker is 2/5. A male, if a smoker is already selected, a male, if smoker is already selected, is 2/3. Okay, so these are the given. Here, from a city population, the probability of selecting a male or a smoker is 7/10. A male smoker is 2/5. A male, if a smoker is already selected, is 2/3. Find the probability of selecting a non-smoker. So what we have to calculate? We have to calculate a small non-smoker. Okay, and a male, probability of male, and a smoker if male is first selected. A smoker if male is first selected. So how to solve this one? Now first of all, we may use this particular formula. So probability of male by S is probability of male intersection smoker, probability of smoker. So here it is 2 by 3, clear, and M intersection is 2 by 5, it is 2 by 5. So probability of smoker is equal to 2 by 3. That means probability of smoker is equal to 2 by 5 by 2 by 3. Okay, so it is nothing but 3 by 5. So probability of non-smoker is equal to 1 minus 3 by 5. Okay, so that means it is 2 by 5. Similarly, to know the probability of male, okay, to know the probability of male, we can use this particular formula. So probability of male and is probability of male plus probability of smoker minus M intersection S. So M union S is what? 7 by 10. Probability of male is, we have to calculate, identify. Probability of smoker is 3 by 5, and M intersection S is 2 by 5. Okay, so probability of male is 1 by 2. And finally we have to calculate S by M. So probability of S intersection male divided by probability of male. So probability of male is 1 by 2, and S intersection M is what? 2 by 5. Clear? So answer is 4 by 5. Clear? Next, we can solve another problem. 60% of the employees of a XYZ corporation are college graduates. Of these, 10% are in sales. Of the employees who did not graduate from the college, 80% are in sales. So what are given? 60% of the employees of the XYZ corporation are college graduate. So assume G for college graduate, A for sales. So probability of graduate is 0.60. Clear? Of these, 10% are in sale. Means if a person is graduate, their in sale is 0.1. 10% is 0.1. Of the employees who did not graduate, of the employees who did not graduate, 80% are in sale. 80% are in sale. So these are given. And we have to identify an employee. What is the probability that an employee selected at random is in sale? Okay, probability of sale. Second, an employee selected at random is neither in sale nor a college graduate. Probability neither in sale nor college graduate. That one was, these two we have to identify. Okay, now we may create that, we may use a table. Now see how much it is possible. Now what is probability of S in by G is what? Probability of S intersection G by probability of G. Clear? Now S by G is 0.1. Okay, and what is probability of G? It is 0.60. So what is S intersection G is 0.1 into 0.6. Clear? So if the table is like that, so if it is G, graduate, non-graduate, sale, not sale, probability of graduate, probability of non-graduate, probability of sale, probability not in sale. Okay, So S intersection G, it is what? S intersection G, it is 0.06. Clear? Now, similarly, S intersection G bar is equal to probability of S intersection G bar. So probability of S by G bar is probability of S intersection G by probability of G bar. Okay. So probability of S by G bar is 0.8. So probability of S intersection G bar is equal to 0.8 into 1 minus 0.6, because probability of graduate is 0.60. So probability of non-graduate is what? 1 minus 0.60. That means 0.8 into 0.4. So 0.32. Clear? So graduate cell and non-graduate, it is 0.32. So probability of cell should be what? Addition of these two. So 0.38. Okay. So probability of cells is nothing but probability of S intersection G, S intersection G bar plus probability of S intersection G. Probability of S intersection G, that is 0.8 plus 0.06 plus 0.32, that is 0.38. Okay. And the next is we have to identify probability of S bar intersection G bar. So how to calculate this one? Now this is 1. Clear? If this is 1, then what about this particular value? So this particular value is 1 minus 3.8. Okay, so that should be how much it is? It is 0.62. Okay. Now probability of graduate, it is 0.60. Okay, probability of graduate, it is 0.60. So probability of non-graduate, it is 0.40. So what about this particular value? So 0.40 minus 0.32, so that means 0.08. Clear? And here should be 0.60 minus 0.06, it is 0.54. Okay. So what about this one? So the answer is what? S intersection G bar, that is answer is 0.08. Okay. Or we may use simple formula. Probability of S intersection G bar is equal to 1 minus probability of S union G. That means 1 minus probability of S plus probability of G minus probability of S intersection G. That means 1 minus probability of cell is what? 0.6. Probability of graduate, it is probability of cell is 0.38. Probability of graduate is what? 0.60. And probability of S intersection G. Probability of S intersection G is 0.06. Okay, if you solve it, you can get the same answer, 0.08. Okay, so we may use table to solve the problem, or we may use formula to solve the problems. Okay, now next, now a bag contains 17 counters, 17 balls. A bag contains 17 balls with the numbers 1 to 17. With the number 1 to 17 means 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, sorry, up to 17. Clear? A ball is drawn and replaced. That means some balls are there. A ball is drawn and replaced. This is called replace. A second drawn is made. What is the probability that first number drawn is even? First number drawn in even and the second is odd and the second is odd. So probability of even. So how many even numbers are there? So 8 even numbers are there. So total 17 numbers are there. So probability of even is what? 8 by 17, and probability of odd is what? 9 by 17. So probability of even is 8 by 17 into 9 by 17. Clear? Now whatever will be the result. Next. Clear? How will your result be affected if the first ball drawn is not replaced? So what happens if the ball taken but not returned back, not replaced, that is without replaced, without replacement? So probability of even should be same 8 by 17, but probability of odd should be 1 less, that is 9 by 60. So the only difference is with replacement it is 17, same ball numbers, but without replacement we are not returning back the balls, so now it is 16, not 17. Okay, and the required probability is probability of E into probability of 0, 8 by 17 into 9 by 17. Okay, next. Now just another problem. If P1 is equal to PA, P2 is equal to PB, and P3 is equal to PA intersection B, where P1, P2, P3 greater than 0, express the following in terms of P1, P2, P3. So express the following in terms of P1, P2, P3. So PA intersection B bar. So for this particular we can write 1 minus A union B. That means 1 minus probability of A minus probability of B plus probability of A intersection B. That means 1 minus P1 minus P2 plus P3, because PA is equal to P1, PB is equal to P2. Okay, and P in A intersection B is nothing but P3. Clear? Now, second, what about A bar union B bar? So we may apply De Morgan's theorem. So using De Morgan's theorem, we can write this one. So this is nothing but probability of A intersection B. That means 1 minus P3. Third, probability of A bar intersection B is equal to probability of B minus A intersection B. So probability of B means what? It is P2. A intersection B is what? P3. Okay. So easily you can use this table to remember the formula, all the formula. Suppose if it is A, then it is A bar. If it is B, then it is B bar. So this is nothing but A intersection B. This is A bar intersection B. Clear? This is A intersection B bar. This is A bar intersection B bar. So here probability of A, probability of A bar, probability of B, probability of B bar. Okay. So probability of A bar A bar intersection B is nothing but probability of B minus probability of A intersection B. Similarly, you can identify the other formula also. Clear? Next, fourth one, probability of A bar intersection union B. So here we can write probability of A bar plus probability of B minus A intersection B. That means A bar is what? 1 minus P1. What is probability of PB? It is P2. And A bar intersection B, A bar intersection B is nothing but P2 minus P3. So P2, P2 minus P3, so plus P3. That means 1 minus P1 plus P3. Clear? Next, what about A bar intersection B bar? So this is nothing but A union B bar. So already we have solved this one. Okay, so already we have solved. The answer is 1 minus P1 P2 plus P3. Okay, next, probability of A intersection B bar should be what? A intersection B bar. So here we can write probability of A minus probability of A intersection B. So probability of A minus probability of A intersection B, that means P1 minus P3. Clear? Next, probability of A by B, that is what probability of A intersection B, conditional probability P. So probability of B is what? P2, A intersection B is what? P3. So P3 by P2. Next, probability of B by A bar is equal to probability of A bar intersection B by probability of A bar. So probability of A bar is nothing but 1 minus P1, and A bar intersection B nothing but P2 minus P3. Okay, so A bar intersection B is nothing but P2 minus P3. That is the end of this particular.